In this video, we will learn about the universal law of gravitation, or Newton universal law of gravitation. Newton was the first scientist who proposed the first law of gravity. We can understand the Newton law of universal gravitation from this simulation we have here. So I have two masses. I can move these two masses on this scale, and I can also increase the mass here. So if I drag this, I can increase the mass, and then for red mass 2, I can increase the masses from 1 to 1000 kg, and also for mass 1 I can increase the mass from 1 to 1000 kg, and also I can increase the distance between them or decrease the distance. Let's say we have here mass 1 is a 436 kg, and mass 2 is, let's make it also near 436 kg. Let's say this is 459 kg. Then we see that the force on mass 1 by mass 2 is 0.000060415 newtons, and the same amount of force is exerted on mass 2 by mass 1. So according to Newton's third law, so there will be equal and opposite force acting on the other body. So the Newton law of gravitation, we can see if we increase, let's say if I increase the mass, we can see from the arrows here, these arrows, when they increase in their length, that means the amount of force increases. So the force increases between these two masses if I increase any of these masses. Let's say if I increase the mass of mass 2 up to 1000, we see here the force on M2 is changed, also the force on M1 is changed. Similarly, if I increase the mass on mass 1, then also the force increases, and if I make them both maximum 1000 kg, then we see here force increases to some amount here which is given here. Let's say if I also decrease the distance, if I decrease the distance, we see the force increases. We see the force increases faster if I increase the distance. Similarly, if I bring them very close to each other, the force increases too much here. So if I decrease the distance between them, the force decreases also faster. So this force decrease between these two masses, but still the force remains the same on mass 1 due to mass 2, and force on mass 2 due to the mass 1. So you can see. So the Newton he wrote this universal law of gravitation in the form of equation, which we'll do here. In order to understand this phenomena quantitatively, which we just discussed here, Newton proposed a formula that says if I have mass, this is mass 1 and this is mass 2, we saw the force between these two masses, which is always attractive. So this guy, you can see here, he pulls it back. That means this mass is attracted in this towards mass 2, and this mass 2 is attracted towards mass 1. So the force of gravity is always attractive. So this attracts this, mass 1, mass 2 attracts mass 1, and mass 1 attracts mass 2. And these guys, in order to keep them away from each other, they have to pull. We saw here the force is proportional to the product of masses M1, M2. If I increase M1, And if I increase m2, the force increases between these two masses. And we also saw that the force decreases, so decrease when I increase the distance. So Newton derived this formula looking into how the force changes between the two masses when they increasing or decreasing the distance. So he saw this relation to be force proportional to the square of distance, 1 over square of distance. So from the center, so from here to here, so this is the r. R is the distance from the center of one mass to the other mass. So we can combine these two relations to give F, that is G, universal law of gravitational constant, mass 1, mass 2 divided by r squared. So this formula explains the force of attraction between these two masses. G is the universal law of gravitation, whose value can be found in physics textbooks. We can easily find how much for mass. So let's say if I have here, so here we have 1000 mass 1 and another mass which is m2, which is 1000 kilograms, and they are at a distance, let's say from here. So these are given in meters. So 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, 6 meter, 7 meter, 8 meter, 9, 10. So total is at 10 meters. So from here to here, so we have 1, 2, 3, 4, approximately more than 4.5. So it is 4.75 meter. So 4.75 meter square, and the G value. If I simplify this expression, I will get exactly this amount of force here. If I plug the value of G, simplify this expression, I will get this amount of force for this particular case. And we know the unit of force is a newtons. You can see it here, the newtons.